Hello, everyone, and welcome to our webinar where we're going to be showcasing how Catalyst Microservices is helping EOfactory.ai perform their processing and more cost effectively analyze 20 years of mangrove habitat on the cloud. So we're really excited that you're able to join us here today, and we hope that you're going to enjoy our show. Before we get started, just like to quickly provide us some housekeeping in terms of how you can engage with our list of panelists here today. So all of your lines will be muted for the duration of this presentation. However, if you wish to ask a question at any point in the presentation, please feel free to do so by typing your question into the questions panel here. And then our team, we have a variety of people on standby that are there that'll try to answer your question live during the webinar. And then also we'll try to get to some of these questions during the Q&A session at the end. And we always post all of our answers to questions on our website when we post the recording. So if we don't get to your questions during this webinar, we'll be sure to get to your questions during to follow up with the questions and post them on our website. So we look forward to engaging with you. I'd like to start off by introducing our different presenters here. So we have Abe Mittal, Jason, who's joining us today as well. So Abe is our special guest he's the CEO of EOfactory.ai. So welcome, Abe.
Thank you, Sean.
Wonderful. We look forward to your demonstration and explanation about EOfactory and how you're leveraging Catalyst Microservices and our other sciences. And then, of course, we have no stranger to our webinars, Jason Flatt. He's one of our solution engineers, and he's going to be here as well to help showcase how you can learn about our microservices. Welcome, Jason.
Thank you, Sean, and hello, everyone. It's great to see everyone. Again, looking forward to talking to all of you, and if you have questions, please post them.
Wonderful. And then, of course, myself, so I'll be your host. My name is Sean Malam, and I'm the product marketing manager here at Catalyst. And my goal here is to basically just help introduce this new product, which is our Catalyst Microservices, help you understand how it can be leveraged and how you can learn more about it and incorporate it into your pipelines and workflows. So we hope you enjoy the ride with us today. So our webinar agenda, we're going to just quickly provide you with an overview of our Catalyst introduction, so a little bit about the brand, but it'll be very short. We're going to quickly provide what our Catalyst microservices are. Then we're going to jump very quickly into EOfactory.ai and showcase how they're able to analyze 20 years of change to mangrove habitat and what the EOfactory.ai platform is and how you can leverage it as well, depending on your interests and how then we're going to showcase how EOfactory.ai is benefiting from Catalyst microservices, and then we'll end with a Q&A session. And once again, don't hesitate to enter your questions into the questions panel. Should you have them, we'll get to them at the end of this webinar. So Catalyst is a brand that was launched by PCI Geomatics. This was launched a couple months ago, and the whole idea behind this brand is to bring Earth data and make it and simplify Earth data for both geospatial professionals as well as non-geospatial professionals. So to make it more accessible to more people. And the idea, we're going to be doing this by leveraging our science that is known and trusted for over 35 years, and we're going to be repackaging it and delivering it in new ways to make it more accessible for today's environment, such as improved processing on the cloud, providing web-based information services for non-geospatial experts, and of course, continuing to enhance and improve our existing technologies such as Catalyst Professional and Catalyst Enterprise, which is our solutions designed for the geospatial professional community. So just a quick look at some of our different product lines. So we have Catalyst Professional. So some of you who have been a fan of ours for a while would understand it or know it as Geomatica. We have Catalyst Enterprise, which is formerly GXL. So once again, these two offerings, we're going to continue to enhance and add new algorithms and new science into them and improve these technologies. But then we have our three new technologies that we've launched very recently. So we have Catalyst Microservices that we just launched a couple weeks ago, and this is the focus of this webinar. We have Catalyst OEM and Catalyst Insights, which is our web-based information services product, which is really designed to target more end users who wish to access and take advantage of geospatial information. So let's focus on the Catalyst microservices. So these are really independent and small independent blocks of workflows or libraries that are really designed to optimize processing on the cloud. And we're going to showcase this new concept and how products and solutions like EOfactory and other web-based solutions, and even how we're leveraging it with our new Insights platform in order to reduce a lot of the bottlenecks and waste that are involved in processing Earth imagery. So before we jump into the actual demonstration and understanding how Catalyst algorithms our containers are leveraged, so it's first important to understand what these are. So Catalyst microservices are really just taking our algorithms and libraries and we're containerizing them into these independent blocks. So really these are standardized building blocks that allow you to then easily plug them into your workflows, and they work really well with other libraries, other APIs, and designed to provide specific sets of inputs and provide specific sets of outputs in a very optimized manner for cloud processing. What makes them special is that they work on any operating system. So it means that they can be deployed in seconds without installation, because these containers, and this is why they call them containers, is that they contain everything that they need to run without having any extra dependencies on an operating system or on any other libraries required that need to be installed. So really they just need to showcase or spin up on a processing server, and they're already ready and initialized to take on work. So this has a lot of advantages for cloud-based processing, because we can have these containers deployed in major cloud environments, so that if there is processing required, we can actually spin these containers up on servers in the same in the same location where the data resides, which means we no longer need to have that aspect in our workflow of downloading the data to the processing server in order to perform the work. So that is a really important concept of what our microservices can do. And one of the big three value propositions of these containers is that we can process right beside the data in the cloud, and therefore save a lot of waste and reduce a lot of waste, such as time and money, in terms of transferring and storing that data into your local servers. And another big advantage is around our microservices is how we price these containers. So these are all based on consumption-based pricing. So it's based on the amount of work that you perform within these processing containers. So for example, rather than having to purchase a large processing system and make an upfront investment and hope that you're going to have enough projects in order to recover that investment, now you can basically know exactly what the cost is going to be for a particular project, and you're just paying for that process. So you're just paying based on the amount of, say, gigapixels or the amount of square kilometers that you're going to process. So it's completely contributable, and it's completely it's easy to align that amount of processing and the cost to the actual work being performed, as opposed to trying to estimate, what is the cost. And we'll go into all of these in more detail. But with that, hopefully that provides you with a bit of an understanding. We're going to come back to the microservices and understand a little bit more about what they are and how and what value they provide. But before that, we'd like to quickly jump into our EOfactory and allow Abe to showcase to you what he's built and the platform that he's constructed, and his organization has constructed, and how they're leveraging our sciences and how they can leverage our microservices in order to provide information services and processing of Earth data to different end users. So with that, I'm going to hand things over to you, Abe.
Thank you, Sean. So what Sean mentioned about processing data, preparing containers on the cloud. So these are the new buzzwords, how you process large amounts of data. So several verticals are seeing, huge level of innovation, especially agriculture, forestry, military, the governments. Someone wants to do change detection, someone wants to do forest detection, someone wants to do agriculture. So how do we leverage some of these technologies? And we have been working closely with Catalyst Earth to embrace. We have been there with them on the scientific side. Now we're looking at how we want to use their technology, put it into the containers and use the microservices so that we move away from the desktop. We have been in the desktop environment for so many years, 30 years, 40 years, we have been doing desktop environment, desktop based technologies. Ever since you see this pandemic which has come, there is a requirement for people to work from homes, work from different locations. So we have built the platform in such a way that you utilize these container technologies, you utilize Dockers, you are able to go and process on the cloud and then be able to share the data. And within hours, you are all connected. The teams are connected. The people have access to the data. Team leaders can assign the work. You can guide the discussions. You can teach each other. You can build the model. So we have built a platform in which you can actually do all your science using the Catalyst Earth and other technologies on the business intelligence to derive the dashboards. So all this under one environment, and that's the EOfactory. We call it Earth Observation Factory. Next. So basically, we want to democratize Earth observation intelligence, deriving information from Earth observation. Every day, even satellites and drones are capturing data. How do we see this data? This data is residing in a very hard, safe. That's what we know. People say we want to keep the data safe, but today's environment, you want to share this data, you want to use this data. 90% of the data is neither visualized or analyzed. So how do you actually get this data into the hands of others so that you can derive some proper analytics out of it? As you can see, the convergence is happening. Remote sensing, machine learning, geospatial intelligence and business intelligence, all of them are converging. So the convergence of all these technologies is what formulates the core of EOfactory. We connect, share and process Earth observation data with ease. I'll show you some demos. I think we'll go through the process in which we will be able to get the data, use the Catalyst Earth to mosaic the data, prepare the data into an analysis ready format so that you can use that data for doing multiple types of application. The overview is we have access to satellite data, not only free data, but also paid sources. You have multiple data sources. You have data sources from Planet, you have data sources from Capella, you have data sources from new satellites which are collecting data on a daily basis. How do you actually get them ready to prepare them for analytics? So we will talk about that. We'll talk about dashboards. We'll talk about very important aspect. Every day you're collecting data, you're collecting monthly data, you're collecting yearly data. How do you analyze? You have so much of historical data, Landsat 7, Landsat 8, you have list 3, IRS data, you have multiple types of data. How do you combine all this data? And today we put it into file formats. We try to find the data, we try to look for the data. You know, how do you organize all this data? And then how do you apply machine learning models to this data to derive the analytics you want? So we will go through the process on EOfactory. So what are the problems we solve? The first problem we solve is the problem of automation. So we automate the processes. We go through the process of automating it, not only for, so yeah, the next slide, sorry. So yeah, this is the slide. So we go through the fully automated process of generating the models. We create the models and then we are able to reuse the training data sets that we have created for certain areas. So then we actually train the system to learn by itself. And then we will show you the process. How do we do it? We have assisted AI so that the AI is assisting us in deriving the information, which makes you don't need 30, 40, 50, 60, 100 people to sit and do the job. You can do it in 10 people and you can do large areas of data processed within hours, which used to take days to process. Next. So what was the traditional method? traditional order the satellite data, then you do the assessment, then you have to buy a desktop software to do the processing, mosaicing, auto rectification, pan sharpening. We remove all these processes. You can order online, you can search for the data online, you can get the data into your environment, share the data within your teams. You don't need to go and copy data anywhere. You can be sitting in any country, you can access the data as long as you have access. You can read, write, or read access, and then you use the platform and use the Docker services of Catalyst Earth to access maybe for a month. You don't need the software for the, for a whole year. You may use it only for a specific project. You pay a fraction of the cost, utilize the service, and then you can finish your project. Then you look for the next project. So you don't invest into capital expenses. And then you build the models. And then once you build the model, next time you have another set of data, you can apply the model because you don't need to train it again. And then you can deliver the data into a format which is in the BI dashboard. You can integrate with Power BI. You can integrate with the industry standard business intelligence tools. Next. Here you see an example, 300,000 square kilometer. The whole state was done in less than 24 hours. So we do a complete color balance mosaic and then do the land use land cover analysis. This is another example of Indonesia where we did a very cloud covered country where you have huge amount of time to select the right data, and then you can mosaic that and get that ready within 24 hours. And the slide which I will talk about is interactive AI. That's what I said, that we built it like a robot. So when you build it like a robot, you give one training and then it starts to prompt you for the next and the next. So this way you are able to actually go and build the entire platform and the analytics based on the AI tools that is available on the platform. So now I'll go to the live demo. Sean, you want to give me the... Okay, so this is the platform. It's called EOfactory. We have a private workspace option and a work share. So you can either store the data only for yourself or you can share the data. Once you share the data, you have multiple people with whom you can share the data, or you can either edit the data or view the data. So you can give your email and then share. So we'll look at some data which I have downloaded for mangrove area. Search for the workspace. This is a work share. Now you see in this worksheet, I've got a lot of data here, which we have already downloaded. The area we are going to work on, the area that we are going to work on is, if I am able to show you the area of interest, this is a mangrove area. So this is in East Godavari. So we are selecting some of the area here, and then we want to select the time series data. We can search the data over here. We have an imagery group where we have paid datasets, Planet, Comsat, and Capella. So there are multiple, both microwave and optical. You can select, and we will have more options for you very soon. We'll have more datasets over here. Once you select these datasets, or you can use the free data sources, like you have for MODIS, Sentinel-1, Sentinel-2, Landsat 8. So you have multiple data sources. What we have here is, we have already downloaded some data. You can see here this data is not mosaic. So if I were to actually select this 2020 data, add it to the map here, you can see this is two types of data. One is on the left hand side and right hand side, and both are not color balanced. If you look at this on the left hand side, on the right. Now, when I actually want, if I want to mosaic, this is where we have the tools from Catalyst Earth. So here we just select this two and we go to the analysis toolkit, where you have option of a very quick mosaic and advanced mosaic. And advanced mosaic is where you utilize the Catalyst Earth signs to create a color balance mosaic. All you do is select this and say, okay, seminar results. and I will just apply this and then say okay, confirm, and I submit this as a task. So when I'm able to when I submit this, it is running in the background in the server. It says it's created a task and it's processing now. While it's processing, I'll go to some other functions. We have this mosaic already done. I will bring in the area here. This is called the test mosaic here, which I have already done. So you can see here, this is the mosaic of these two data, which was basically the left hand side, both are not color balanced. Here it is color balanced. If I were to actually go and look at the false color composite, I can select the bands. I can define. These are all available on the platform. You can go and change to different viewing mechanisms, different. You can cut the histograms and you can apply. And then you can see here you've got a false color composite. And you can zoom in. This is all I'm working on the cloud. Zoom in, zoom out. You can then go and define your training data sets. And so what we want to do is we want to look at time series data. So while it's doing that, I will see whether it is 85% complete. Just now I have submitted the advanced mosaic function. It is running on the on the services of Catalyst Earth, and it's generating the mosaic. So once it finishes, I should have the same mosaic generated once again. It takes me less than a couple of minutes to generate this mosaic. So while it's finishing that, I will go and show you some of the data that we already have here on the mosaic, which is Sentinel-2 to 10 meters, Landsat 8 to 15 meters, Landsat 7 to 30 meters. So these are all the different data sets. 2001, 2000, 2002, 2003. I can add to the map. They're all old data. If I were to actually enhance them, I can enhance them. They are also all 4-band data. No enhancement on the contrast. If I want to enhance it here, stretch to min max. Okay, apply. And there you go. I can see the data. So I can stretch the data. Now, while it is doing that, let's see, it has finished here success. So you can see here it has taken from 22, 21, 21. So it has taken that much time. Let me go and check the data. It is in the root here, seminar results here. I can add this data. So this is the data which I just showed you. Again, it has generated the mosaic, and right in front of you, you can generate very large area mosaics. I will show you before we exit here. I'll show you some mosaics that we had created. While it's doing that, I wanted to show you 2003, 2002, 2000, 2001. So we have multiple data sets. I see here mosaic of Landsat 8, Sentinel-2. So these are all the different data sets. We can add to the map. Again, all these data sets are available to use. Now, what we do is we perform analysis ready data to align all of them together, because if we were to do any kind of time series analysis, we have to run through the time series interface. So we have Rolodex here. Rolodex is a time series data management backend tool which is storing the data. So I have here Mangrove, which we just downloaded. All the data that we have downloaded is reading the data. This data management is basically a data cube which stores the data in the X, Y, and Z format, in which you can see that the data is stored in multiple years, and then we can select which data we want to use. So this is how you store the data. Now, if all the data is in multiple resolutions, multiple formats, when you submit for processing in a data cube, you will be able to bring them all into a single resolution and process them without having to change any resolutions. So if you're doing a research project on coastal zone, if you're looking at the changes in coastal zone erosion, you can actually use the data cube to go and do the analysis. So we have an example of change in forest or change in the crop condition. We call it forest degradation. It is looking at the NDVI changes over time. So I have an example here which is basically for the same area that we had here, and we have gone through the different years of data, you can see that there are some areas of change. I'll just zoom to one area, and this area talks about some changes. So if I click on the pixel, it goes through the time. It goes through the time. You can see on the left hand side the NDVI changes. It's doing on the fly calculation. So 2018 to 2021, 3 years of data, and it goes and plots. So if I want to see the data on the in 2019, I can actually take it. You can see there is a small clearing here, and then you can go and compare all the changes, and it is looking at the time series data. So you can move through this. You can bring in other layers of data. You can bring in other background data, and you can use this background data for your reference points. So what I want to show you is that the the platform allows you to store time series data, because that is quite important when you do land use, land cover, when you do other types of analysis. You need to access the information in remote sensing, is especially for time. So if I were to look at all the different types of products that can be used over here, let me show you one more very quick one here, that what kind of space that we can use here. So if I show you the very interesting uh, data here, we have data which is for the mosaic of 3 states that we have created here. This is the 3 states mosaic which is created here for in India, UP, Rajasthan, and Madhya Pradesh, which is like nearly more than 1 million square kilometer. This entire mosaic, which is color balanced mosaic, and which was done within 24 hours. Selection of the data, the preparation of the data, the mosaic of the data, you cannot see any seam lines here. So all this data was done. How do you select the data? We select the data by using the interface. Say for example, I want to do India data. I can select the area. I can select which sensor I want to download. Sentinel-2. I can do seasonal download, or I can do date range. So these are the tools which are available. So if I say that I want to look at the data within January and February and cloud cover of 10%, and I want to search the data. So what it does, it goes and does an online search, and now it is searching for the images, and then you can select the data which you want to create the mosaic. So it is now searching the data, and you can see here that you can see the preview of the data which is being searched. So the entire India data you can search within half an hour. You'll be able to select the material that you want to select. If you don't like the data which is cloud covered, you click on it, and then it'll tell you, okay, you don't want to see this data, maybe you can select another data, and it changes the data. So you can select the material. These are available online. Everything is online. So you are able to go search the data, prepare the data on Catalyst Earth, and then generate the mosaics, generate the analysis ready toolkit, do haze correction, do atmospheric correction, and be able to get your applications which you need. So I have gone through with you in a nutshell about what tools we have built. We have more tools for agriculture. We have more tools for business intelligence dashboards. So we are available anytime. Please let us know. We will share with you more details. How do you take this to the last mile? And then you will be able to utilize this for your own. And everyone is the platform is free for signing up. So you may sign up anytime, test it out, and if you need to use more, please let us know. We will help you out. And then there are team members who can give you training and help you out with it.
Wonderful. Thank you so much, Abe. That was a great demonstration and a great example about how you can leverage Catalyst Earth, our sciences, our technologies, and our and we'll showcase a little bit more about how they'll be able to leverage our microservices in order to even enhance this service for their own business. And these are the kinds of applications and solutions you can build with Catalyst microservices. And then, of course, for EOfactory, their services is, in my opinion, fantastic, and I've had the opportunity to use it. It's very seamless, very simple user interface. So I recommend if you're looking for a kind of solution like this, and for some of the applications that Abe was able to show you, I highly recommend looking into EOfactory.
Thank you, Sean. Our goal is that everyone should be able to utilize the data. Don't spend 80% of the time in preparing the data. Spend 20% of the time preparing the data, 80% analysis. That's the most important part.
Exactly. Wonderful. Well, thank you again. And at this point, we'd like to move things over to our first survey question and involve our audience here. So we would like to just simply ask, do you use time series analysis and in your work today? So simple yes, no questions, something light to get us started here today. So I'll launch the poll question. So right now you'll see it in front of you, and it's a simple yes, no. We'd just like to know if you're actively using time series analysis in your work today. And we'll let our audience answer this question, and we'll give you a couple minutes to go through. And already we're getting a lot of votes in, so over 50% of people have already voted. And it looks like an overwhelming number of you are actively using time series data. So currently hovering around 80% of you today are using time series analysis in your work. So a great example or a great solution to support and enhance your work and be very cost effective is EOfactory. And once again, they're leveraging our technology under the hood, such as our analysis ready data technology, our mosaicing technology. And we're going to showcase in just a moment here about how they can, how we're working with them now to be able to leverage our microservices to even further improve their solution and services and make and provide an even improved or an enhanced service to you. Okay, so we'll give you another 10 seconds to get in your votes. 75% have voted so far, and so if you haven't voted, please vote, and we'll share the results with everyone in a moment. All right, I'm going to close the polls in 3, 2, 1, and we got about 80% of people voted. So we'll just share these results with everyone here today. So you can see that about 78% of you said that yes, you're working with time series analysis, and 22% no. So we'd love if you'd love to answer into the questions panel. Let us know what you're doing. If you should feel free to do so. And if you're not, we'd love to know if you're interested in beginning to work with time series analysis. All right, so we'll move on with our presentation. So we'd like to just now bring things back to the Catalyst microservices and begin to explain how something like EOfactory and how our Insights platform is, we're leveraging Catalyst microservices and what it can mean and what it can do for you. So one is moving the processing, not the data. So right now, Abe is leveraging our sciences and our technologies using our enterprise solution. So he's got a server-side system in his back end that's doing the processing. But as we help him and we're working with him right now to migrate to our microservices, where you saw that he was downloading the data to the processing server, and there's a time it takes to do that, now he'll be able to move the process and do those mosaicing processes, those ARD processes, and anything else that he's leveraging our technology and sciences for. And he'll be able to do that right where that data is stored in the cloud, which is going to save him time, money, and be able to ultimately deliver a result back to you even faster than what he's able to do today, which we think is going to be a major advantage to his solution. The other one is limitless scalability. So I'll have to qualify this in a little bit, but limitless scalability basically means that we're no longer going to be hardware bound by in terms of parallelizing batch processes. So we'll get to this in a moment. And then the final one is cost predictability. So for any organization, whether you're government or whether you're business, this is an incredibly important aspect about being able to know what is your cost going to be. And especially if you're building a service like EOfactory, you want to know that what your actual cost for doing a specific process, as many of his customers come on board and they register to his platform and they want to perform specific projects. It's easier if he knows exactly what the cost of processing that imagery is going to be. It's easy for him to build that into his business model. So let's take a little bit of a deeper look at these concepts. So we have move the process, not the data. So this is really the idea that you can take our microservices, so our different libraries, and we're going to showcase this. And rather than downloading the data to the processing server, you're going to move the process to the data center where the data is already stored in the cloud. So that way we are going to save you time, because the data transfer, as everyone I'm sure is aware, Earth imagery is incredibly heavy. They're very large data sets. So to transfer that data to a local or processing server, or even another processing server in the cloud, can be a very timely operation, as well as it's very expensive. The average cost of moving data from one cloud to another cloud, or downloading data from a cloud provider, that just the transfer rates are around 20 cents per gigabyte. So that can really add up when you're working with large imagery such as Earth data. The next one is cost predictability. So this is a really important concept because it comes with the consumption-based model. So rather than having to make an upfront purchase, or even a subscription-based purchase of a system where you would have it, where you would invest in a system, either for a period of time or for or take ownership of it, and then you hope that you get enough projects to cover the cost of that subscription or purchase. Using our consumption-based model, it eliminates any of that risk, because you're really just paying for the actual processing you're going to do, because our payment plans are based on the gigapixels or gigabytes that you're going to be processing through the algorithm, or through the microservice. And this includes all the infrastructure costs, it includes the hardware costs, includes the data acquisition, and of course includes the software itself. So all of that's built into that price, so that you know exactly at the end of the day, when you get your output results, you'll know exactly what that cost is going to be, and then you can incorporate that into your business model, which eliminates a lot of risk around accessing these kinds of solutions. And then limitless scalability. So I got to qualify this a little bit. Obviously, there's no such thing as infinite scalability in the end. But what this really means is that there is a vast amount of cloud resources. And this is actually a quote or a statement that I'm paraphrasing from Amazon AWS. They basically said that if you have enough processing, and you can perform enough processing for us, we can stand up enough servers to support it. So basically, what we're doing is we're eliminating the need of having to scale, or eliminating the barrier of only being able to parallelize a certain number or a small set of images at once. So let's imagine here, in a traditional process, you'd be downloading the images from the cloud. You then would process them, say they're sequentially, or maybe you can parallelize them on a processing server, on a set of processing servers, and maybe you can do 10, maybe 20, maybe even 30 at a time, which is great. But if you want to scale up, you need to add more hardware. You need to pay for more licenses. You need to do a variety of things, and it's going to cost you to scale, to add more, to be able to process more images in parallel. Well, we eliminate that through the consumption model within and how microservices are designed. Because rather than downloading the imagery, we actually move the microservices to the cloud where the imagery is, and we can spin up basically as many microservices as there are images in a batch process, and we can run them all in parallel at once. And at the same cost as if you were to run them sequentially, because it's a consumption-based model. So let's take a quick example or look at this. And this is basically, we'll go through this very quick project example. So let's imagine you have 10,000 satellite images. You don't have a software solution. You have access to 2 local processing servers. And in both scenarios, it's going to take 5 minutes to orthorectify each image. And then in the end, you need to deliver those ortho images to your customer. So let's start at the bottom with the current scenario. So you start off by estimating the cost. So what are the hardware costs? What's the software cost? How much am I going to need to support this? And it's difficult because you need to get those licenses, and how much do I allocate towards this project? So there's a lot of time and a lot of uncertainty around just estimating the costs of what you're going to need to be able to perform this project. Then you need to purchase software licenses, allocate hardware, which also takes time. and there's an effort involved there. Then let's imagine you need to install and configure the processing servers. And let's say, this, we know from our experience that this takes usually a day or two, but let's imagine you can do this in 4 hours. Then you have a learning curve, let's say is 4 hours, and then you build the workflow, which say takes 2 hours. So that's all the project setup. Then running the project itself. So you need to download the data. So let's imagine you could download 10,000 images in 12 hours, which we think is very, very fast. It's probably going to take you a couple days to download, say, 10,000 satellite images. Then you need to process, and let's say you can process 10 images in parallel on your 2 local processing servers. So at 5 minutes per image, this would take you about 3.5 days to perform this, to orthorectify all 10,000 images. And then finally, you transfer the files to the client, which takes another 12 hours. Now let's compare that to the microservices world. And in total, this project was 5.5 days. So now in the microservices world, we have the same 4 steps. So you still need to cost it, but you register for the microservices and you can be able to estimate an exact price of what this is going to cost based on the amount of imagery and the type of process you're performing. Then we eliminate the need to purchase software licenses, and we eliminate the need to allocate hardware. We also eliminate the need to install and configure processing servers. So those 2 steps are completely gone. Now there'll still be a learning curve, and there's still the building of the workflow. So let's imagine that that's equal. So now that's 6 hours in total for project setup. Now running the process, this is where you get a huge advantage. So let's imagine rather than downloading the 10,000 or the microservices, they initialize where the imagery is located. So we can initialize 10,000 microservices for orthorectification, and let's say under a minute onto this cloud process, onto this the cloud environment. And then it can then take those 10,000 images and process all 10,000 in parallel at once. So the whole project is now completed in 5 minutes, and that would be the same cost as if we were processing each 10,000 in sequence, because it's a consumption-based model. So now this entire batch process, which would have taken 3.5 days, now takes 5 minutes. And then we still need to deliver the final results to the client. In this case, the client wants it on their local service, so we have that 12 hours. So now we've taken this scenario, and we've gone from 5.5 days down to 19 hours. So I'd like to, at this point, showcase how you can learn more about Catalyst microservices. So basically, if you would, you can go to our website. So you can go to catalyst.earth, and then you can just look at products, and you can find microservices. And if you wish to learn more, we have Jason Flatt here, who is from our solution engineering team. He's going to very quickly show you and one example of how his team can help you get an opportunity to sort of kick the tires or be able to work with our microservices and learn our sciences and technology to see if it's a fit within your pipeline. So with that, I'm going to hand things over to you, Jason.
Thank you, Sean, and hello, everyone. So as Sean mentioned, my team and our whole goal is to help users explore our technology and our API to provide a way for users to discover and to learn about our technology and our libraries and what products that they could generate with our science and with our microservices, and how it could integrate into their current workflows and be set up next to your data. So what I want to do as I share my screen is just an example of to showcase just an example of a microservice that we're launching for specifically deformation mapping. As it is accessible on a Jupyter notebook, it's a great system for those who are interested in exploring our technology, where they can also access it, run different operations, test the different scripts and the libraries out. So it's a really great tool. But as mentioned by Sean for this, we want to bring our solution to the data. And what we're doing here is we're making use of a cloud provider to access Sentinel-1 data catalog. And here we're going to access it and perform a deformation map. What we do first is we could select and generate a query for the Sentinel-1 images based upon specified parameters, be it an area of interest or specific dates. And then can access the data, query it, and then process it with our INSAR deformation workflow so that can generate the final deformation maps, which can then be analyzed either in the notebook itself, either with raster.io. So we can just look at potential deformation, coherence, array of statistics, or we can actually download it on our own system, on our own machine, and visualize it and QA it and analyze it in, for instance, Focus. So what I have here, for instance, is just the deformation map of a little area, and I actually overlaid it with a Landsat 8 image just to understand where I'm looking, but I can just quickly look and see the amount of deformation occurring. So in summary, my team and I are happy to schedule time and meet with those who are interested to explore how our microservice system can work for you.
Wonderful. Thank you so much, Jason. Really appreciated that. And yeah, as Jason mentioned, we really want to be able to show you more. We really want to have an opportunity to have a conversation with you and show you what you can do with microservices and how our library can fit within your data processing pipeline. So please contact us, and we'll be more than happy to show you a little bit more and work with you so you can learn our sciences and our microservices tech. So we'll just we know we're running a little bit behind schedule here, so we really appreciate you giving us this time. So we'll just finish off here with a couple just highlights about what our release focus. So right now with Catalyst Microservices, our main focus in terms of how we're going to be releasing our library, our sciences to microservices is we're going to be deploying first on major cloud providers and industry-specific cloud partners. So these include partners such as Up42, which actually we have an announcement coming up very shortly, so stay tuned for that. And then we also have we'll be working very closely and already working on AWS, Microsoft Azure. So there's a variety of these major cloud providers that we're also focused on releasing our libraries, our microservice libraries to. So and let us know and contact us if there's any specific cloud partners that you would like us to work with as well. In terms of our release focus, in terms of the library, so we have over 750 algorithms and many more workflows. So there's over 1,000 combinations of algorithms and workflows. Our focus right now, where we're starting off, is we're first launching some INSAR workflows as microservices, and then and analysis-ready data workflows. So this is looking at like radiometric correction, super registration, multi-resolution analysis, image fusion, as amongst more. So these are our focus right now. But once again, speak with us about deploying other workflows and algorithms. We'd love to work with you closely and understand which of our algorithms and what science and are you interested in deploying as a microservices to support your process. And we're very agile in terms of being able to prioritize the microservices or our release of microservices. So we look forward to working and communicating with you. With that, we'll do one last quick poll, and then we'll open things up for Q&A. So at this point, I'd love to understand what cloud provider / platform are you currently processing or wish to process Earth imagery in? So some of the options include Amazon AWS, we have Microsoft Azure, Up42, Creo DS, or is there other or none? And if so, we'd love to hear from you in terms of where you would like to deploy. So as we go through, it looks like we have a vast majority of you right now that are saying other or none. So if you can please specify. So we have about 68% of you today that are saying other or none. And then about, it's actually a tie of approximately between Amazon, AWS, and Microsoft Azure at around 20% each. So it looks like those are the two platforms that are most commonly used today. And then we have Up42 and Creo DS are also popular platforms as well. So we'll give you just another couple minutes to enter your votes, or sorry, a couple seconds to enter your votes. Maybe 10 more seconds, and then we'll close off and share the results. Okay, so if you haven't got your votes in, please get your votes in now. I'm going to close the poll in 3, 2, 1. Okay, and let's just share the results so we can see this is still a fairly new concept. So we have Amazon AWS and Microsoft Azure are the most popular cloud platforms that are listed here today. We have 71% are saying other or none. So we'd love to hear what those ones are. And to see if just to understand those. And then we also have Up 42 and Creo Diaz, which are more industry specific ones, which are also are showcased as well. So thank you very much for entering your vote. And we'll just finish things off here with a quick questions and answers. So a lot of questions came in as we were presenting, but if you have any questions, now is a great time to ask those questions. And we'll just spend probably 2-3 minutes because we're already over time here right now to answer a couple of these questions here. So one of the questions that was asked, I'm just going to go through our list. So one of the questions asked, will ESA and Landsat support your Docker? So in terms of our microservices and the way that we're looking at supporting them is we will be supporting all of these different data, especially the open source data platforms, as well as many of the commercial data platforms. And because they're already storing their data in the cloud, we'll be able to access. We know which data center their imagery is being stored in. And therefore, the way these microservices work is that we just spin up a process on a server in that data center, which means that we can access it through their local network and directly access that data. And that's how we spin up next to the data. So we're able, and very quickly, so long as the data is already residing in a data center, we can support that data center, which makes us very agile to be able to support both open as well as commercial data. We have another question for EOfactory. So one of the questions, Ave, is EOfactory free for use?
The initial work can be done on EOfactory for free. We give some free usage of the platform and data storage. And beyond that, if you have a big project, then you need to pay for the data storage and some of the services that we license from Catalyst Earth. We'll be happy to share the pricing. It is a fraction of what you pay for using a lot of the other desktop-based software. So yes, there is a price to be paid, but that is after you have actually utilized your initial consumption of the free data usage in the platform.
Wonderful, thank you. And this will be the last question we'll be able to get to today. Unfortunately, we ran a little bit over time, but as I mentioned, we will be sure to answer all of the questions that came in, and we'll post all those questions up on our website, all the answers to those questions on our website, and we will send out a email when the recording and the answers are all posted. So unfortunately, we can't get to all of your questions today, but once again, we will be sure to answer every single question that came in, and we will post this on our website. So we really appreciate the time you spent with us today. So on behalf of Catalyst and on behalf of EOfactory, Abe, we really, once again, thank you for spending this part of your day with us. We hope you found this webinar informative. Thank you again.
Thank you very much. Thank you so much. Thank you everyone for attending the seminar.